Hello everyone, and welcome to my YouTube channel. It's actually new, so I created this for my colleagues at Cybersecurity at TechCrunch. So let me just get right on point. Today we are what you're seeing on my screen is a network segmentation. It's a real world network simulation using the software called Cisco Packet Tracer CPT. So that is what we're using. So what is Cisco Packet Tracer? Basically, Cisco network simulation software developed by Cisco System. We all know that it allows you to design, build, configure, and troubleshoot virtual computer networks. So that's basically what it's used for, and it's used for educational purposes for students like me and also professionals like our tutors. So that is what we that is what Cisco Packet Tracer is all about. So what do we have here in my screen, or on my screen rather? We have two offices. So let me use my mouse to show that we have two offices. We have, this is office A, which is made up of two PCs. An office basically, we don't care about the desk or the windows or whatever right now. So for an office, we understand that computers are meant to be there. So we're taking the computers into as the main subject matter. So we have PC1, PC2, which makes up Office A, and we have the PC2, PC3, or whichever way, because basically programming starts from zero. So when you're programming, it starts from zero. So this is basically zero means one, which is the first on the index, and this is like two. So this is like Office A. I should be able to edit that. Yeah, Office A, so you can be able to know that this is Office A, which is made up of two PCs, and we have Office B, which is made up of also two PCs. And what do we have here? I just want to make this video as short as possible. And so this one is we have the switch, and so these PCs are connected to the switch, and we also have for the Office B, we also have the two pieces connected to a switch, and both switches are connected to the router. So first of all, what is a switch? Actually, their role is to manage traffic within the office network itself, within the local network itself. Switches are meant to manage traffic, meaning they are meant to they're meant to allow two pieces within a local area network to communicate to each other, and that's why you have this PC and the other PC, or PC A, PC B, or let's just say PC 0, PC 1, to communicate to each other in the center. So meaning that I can send data from here through the switch and it goes down to here. Same thing here, I can send data from here and it goes down to this place. So what are switches? It allows two PCs in the same office to talk to each other efficiently using their MAC address. And we understand what MAC addresses are now. We understand IP addresses. I mean, we've been taught about it. So the identification of an hardware itself, the identity of an hardware itself, is what we call MAC address. And when you're on the network, what do you need to identify a device? When you're on the network, maybe internet network, maybe Bluetooth, mostly internet network, um what is the address that we use there? We actually use IP addresses. So so now these switches, now we understand that switches allow communication between two PCs or two or more PCs. It can be as many. You can have as many, you can drag as many as you want to, you can just undo all that and all that. I'll just click on it and delete device itself, meaning it connects the two offices together. Remember, the switch itself tells you that okay, oh, this is an office, because it is like the single connection connecting all PCs. So the switch itself tells you that okay, this is an office. This another switch tells you okay, this is another office. So what is the router itself? What is this router itself? The router is a crucial device that connects two separate local networks. So let's say office A local network and office B uh, local network. So it operates at layer 3. And what do we have? What is the layer 3, which is the network interface? So, and it uses IP addresses to determine the best path for data to travel between networks. Understand the IP address is all is it's you can only see IP addresses, or you can use IP addresses when you're on the network. MAC addresses are for physical devices. That's why that is how you identify physical devices, and the IP is a network device, or a device that is connected to the network. That is how you identify that. So that is the basics for this. I don't want this video to be too long, so this is the first video. I'm going to show you how the network was set up, or the setup of how a network looks like. And in the next video, we're going to start from scratch. We're going to build from scratch, meaning adding these pieces, adding as many pieces together, and connecting them, giving them IP address, and also pinging. So let's say for instance I want to ping, let's try to ping this PC 0, which is basically the first PC. So when I hover over this, you can see that it has IP addresses. We have device name is PC 0, device model PC this, and we have ports. What are the ports? And you have fast internet, the link is up. And what are the IP address? We have 192.168 1 and then dot 10, and all that. And same thing here, you understand. I give this one also an IP address, and it also has its own MAC address itself. So they all have IP addresses and all that. So let's try to ping this. So let's try to ping this. So first of all, you go to um, the desktop, and you go to the command prompt, and you try to type just ping, and you press enter key, and you can see that you're getting replies from this. As long as you're able to get all these replies, and you're able to get the fact that you didn't lose any data, so that means that it is communicating. It is communicating. It is I think we didn't see that. Let me ping again so you can see it clearly. You can see the data moving across from this PC to other PC. Let's do that again. Okay, still on. So let's ping 192.168. That's 1.11. Let's, because that should be the IP address. Now you can see. So let's ping so yeah, let's try to ping PC1. So so how do we do this? So you open the PC1, open the IP on that desktop. um on that desktop you can find the IP configuration. So let's try to ping the other PC. So we'll just round it up for today. So this is the IP address is 192.168.1.11. So when you ping that, and when you look at the network moving, it's moving. First time might be quite slow. Just like our tutor said, when it's all green, and as long as it moving, okay, you're able to see it moving and all that. So as long as you're able to get those replies, yes, as long as you're able to get these replies, as long as you're able to get these replies, and on packets being sent and none being lost, that tells you that your connection is okay. So that as long as when it's all green, that means you have a solid connection, and when you're able to get these replies, it means that your connection is okay. So that is all on just testing our networks, um our network rather. So that is all for today in this video, and so this is how our network looks like. So we were able to learn about the basics of the local area networks, what makes local area networks. We you know the PCs and the switch makes up a local area network, makes up also Intel makes up an office, and you have these offices connected to the router or itself, so which gives internet access, and meaning you're able to communicate between the two offices and all that. So remember, the PCs within a local area network communicate through the switch, and offices communicate through the routers and all that. So that is all for today. The next video, we're going to start from scratch. I'm going to show you how you connect all your PCs, your switch to your router, and you configure your connections and all that. So thank you for watching, and don't forget to subscribe.